This is a JAMB physics problem. It says that a force 10 Newton drags a mass 10 kilogram on a horizontal table with an acceleration of 0.2 meters per second squared. If the acceleration due to gravity is 10 meters per second squared, what is the coefficient of friction between the moving mass and the table? So let us sketch the table. So let us assume that this is table. This is the table here. We have a mass, a certain mass. This is 10 kilograms. That implies that we can find the weight of this mass acting downward, which is mg, and that will be 10 times 10, and that will be 100 newton. This is being dragged by a force. Let us assume that the force is dragging it to the right, and then the force that is dragging it is 10 newtons. The implication of this is that since there is friction, it implies that this surface is a rough surface. And if this surface is a rough surface, to know the direction of friction, all you have to know is the direction of motion, because friction does not necessarily oppose the direction of the applied force. Please take note, it does not necessarily oppose the direction of the applied force. Rather, it opposes the direction of motion, which implies that if you want to know the direction of friction, you need to know the direction of the resultant force, because the resultant force will be the one responsible for the motion. You can have an applied force which is not going to be responsible for the direction of the motion, because there are other forces acting underneath in the system. So the first thing you want to know is the direction of motion. And once you know the direction of motion, then you can know where your friction would go. In this situation, we know that the intended direction of motion is by this 10 Newton force, which is to the right. Then that implies that the direction of friction will be to the left. So this is the frictional force going to the left. Of course, we know that there will be a normal force acting in this system. The normal force goes up like this. So I'll be calling my normal force, I'll be calling it R. Having this all set up now, we will be using the Newton's second law of motion to derive the equation needed to solve this. Let me start with the vertical component. For the vertical component of this motion, we realize that we only have the normal reaction and the weight acting downward. And if we express that, that will be R minus 100. Normally, according to the Newton's law of motion, the net force acting on the system will be equal to mass times acceleration. But this is the vertical direction. As we can see, the mass is not going to move in the vertical direction, which implies that its acceleration is going to be equal to 0. So ma will be equal to 0 in this place. So the implication of this is that R equals 100 newtons. This is not always the case. It depends on what the question is talking about. Let us look at the horizontal component of this motion. For the horizontal component, we have 10 minus Fr equals ma. Of course, because it's accelerating in the direction of the force that is acting on it. 10 Newton drags it and it is giving it acceleration of 0.2. So if we put that into this, we have 10 minus the frictional force equals ma. So the ma will be, mass is 10 kilograms, and then this is 0.2. The implication of this is that 10 minus the frictional force equal 10 times 0.2, that is 2. If we do this arithmetic, frictional force will be 10 minus 2, which will be 8 newtons. The implication of this is that it experiences a frictional force of 8 newtons. The question I want us to find the coefficient of friction between the moving. By the way, because this is a moving body, the coefficient of friction we are looking for is the coefficient of kinetic frictional force. Now, there's a relationship between the frictional force and normal reaction. The frictional force equals the coefficient of friction multiplied by the normal reaction, which implies that the coefficient we are looking for is the frictional force divided by the normal reaction. And this implies that we have 8 divided by 100, which is 0.08. Then the result of this shows that the coefficient of friction between the block and the horizontal surface is 0.08. If you like this video and you want to see more of it, subscribe to my channel, like, comment, and share. I'll see you in the next one.